Alright guys, I wanted to make this second video so that you could have more examples of completing the square when a is not 1, and also just give you some tips for doing this worksheet because I know it's a lot of questions and they're all dealing with completing the square. So, number 4, I believe is the first question where we need to use completing the square where the a value is not 1. So, let's dive through this question. We get 3x squared when we subtract the 2x and add the 6 over to the other side. We get 3x squared minus x plus 6 is equal to 0. So now we need to go through this question, and our a value is not 1. So we're coming in here, and what I would do is I would go 3x squared minus x plus 6 is equal to 0. We need to factor 3 out of both of these terms. So what that's going to look like is 3x squared minus 1/3 x. We're going to put our plus and minus also inside that parenthesis. The plus 6, or the c value, goes outside. Now we take half of that middle term. So negative 1/3, cut it in half, is negative 1/6. And we're going to square it. So that would give us 1 over 36 here, 1 over 36 here. We've now made our perfect square trinomial. So that's 3. And it's going to be x minus 1/6 squared. And then it's going to be minus 1 over 36, still in that parentheses, plus 6 is still outside. And then we distribute the 3 back in. So it's going to be 3x minus 1/6 squared. 3 and 1 over 36 is going to make negative 1 over 12. Plus 6 is equal to 0. And then now we can make this into 12, so 6 times 12, what is that? 72 twelfths. So now I have 3x minus 1/6 squared, and then that's going to be plus 71 twelfths is equal to 0. And this is a solving question, so we're going to have to do a little bit more work here to get x by itself. So what I'm going to do is subtract that 71 twelfths, so we have, come up here, 3x minus 1/6 squared equals negative 71 twelfths. Divide by 3 on both sides. X minus 1/6 squared is equal to negative 71 over 36. Remember, dividing by 3 is the same thing as multiplying by 1/3. So then we can square root both sides, and we get x minus 1/6 squared is equal to plus or minus the square root, or I, square root 71 over 6, because the square root of 36 is just 6. Sorry, the squared is not there anymore. And then we add the 1/6 over. So x is equal to 1/6 plus or minus I radical 71 over 6. Okay, so that's one example where the a value is not 1. And we have to do some solving. So I do realize these questions can get kind of long, guys, but I need you to do a lot of them because we need to memorize the steps to solving these. For these next questions, guys, rectangle, base times height equals the area. Parallelogram, same thing. Base times the height would equal the area. For your triangle, 1/2 the base times the height would be the area. And then for the trapezoid is a little bit different. That's going to be 1/2 the height times base 1 plus base 2. That's the area formula for a trapezoid. So this one has a little extra work in it, just because you're doing some double multiplying before you can even complete the square. So these ones, still all completing the square questions, okay, but now you're just working with area formulas. What I wanted to take a look at next was, we'll look at one of these, converting to vertex form. So let's do another example where the a value is not 1. So for 13, we're going to come in here. We're going to say y is equal to 2x squared plus 24x plus minus plus 25. Remember, we're going to set this into parentheses, and we're going to pull the 2 out of both of these. So y is equal to 2. Now we have parentheses x squared plus 12x plus minus plus 25. Now we're completing the square with this b value, so 12 over 2 is 6. 6 squared is 36, so we're going to fill 36's in here. In order to do the next part, factor here, you can distribute the 2 to the 36 right away and then pull it out. So that's going to be 2, and that's x plus 6 squared. 2 times 36 is negative 72 plus 25. And so then our final answer here, negative 72 plus 25, so 2 times x plus 6 squared, what is that, 50, 43, negative 43, did I do that math right? Let me double check in my calculator. 11, negative 72 plus 25, yeah, oops, negative 47, sorry. Okay, this would be vertex form, so you're all good right there. Okay, so hopefully that gives you a good idea of how to do 14. So then the last question here that I wanted to look at was 16, because there's a lot of decimals and it can get kind of crazy if you watch the notes with a lot of decimals. So when you walk x meters per minute, your rate y of energy use can be modeled by this equation. Okay, so it wants us to just complete the square in this question because it's asking us to find the vertex of the given function, then state what the vertex represents. So we have to complete the square to get it into vertex form. So in this case, we're going to say y is equal to 0.0085 x squared minus 1.5x plus 120. And then what I'm going to do is we're going to bump that 120 out, insert our plus and our minus, throw this in parentheses. Now we're going to pull that 0.0085 out of both of those things. So I need my calculator to do 1.5 divided by 0.85. So 1.5 divided by 0.0085. So that's 176. So y is equal to 0.0085 parentheses x squared minus 176.47 plus minus plus 120. And then from here we need to complete the square with that number. So 176.47 divided by 2 gives us 88. So this is 88.235, and then we square that number, it's going to be big. So that's 7,785.415. So 7,785.42, 7,785.42. And then now we have perfect squared trinomial here. So y is equal to 0.0085. We have x minus 88.235 squared. And then remember, what you can do is you can multiply the 0.0085 by that last term to pull it out. So if we do that, we have multiplied by 0.0085 equals, so that's going to pull out and become negative 66.1. We'll just go 18 plus 120. So then to finish simplifying this, we have y equals 0.0085 times x minus 88.235 squared, and then this plus 120, 66.18 negative plus 120 is equal to positive 53.82. And then here's our vertex, right? Our vertex is at 88.235. So 88.235, comma 53.82. And then what does it represent in this equation? It says x is meters per minute, so we're walking at 88.235 meters per minute. And then the calories, the y is our calories. So what we can say is when walking 88.235 meters per minute, you burn 53.82 calories per minute. That's what the vertex is talking about. Awesome. And what is that? That's the maximum calorie burn for what we did was we really just maximized our calorie burn for our walking meters per minute. All right. So if you have any questions on this, guys, always ask them. I hope these couple extra examples were helpful, and this video wasn't a waste of your time. But as always, shoot me a message on Canvas or on email, and we'll go from there. I hope you guys have a great rest of your day.